Thank you so much for watching this video. Today we're gonna be talking about vertical projectile motion. If you are doing grade 12 in South Africa, physical sciences, the CAPS is one of the topics that you will be dealing with, that you need to know very well, as it carries quite a handful of marks, right? So we're gonna talk about projectile motion, what it is, and how to go about solving these types of problems. Just a disclaimer, please note that this video is going to be longer than most of the videos on the channel, but that is because I wanted to show you multiple ways of how to go about solving problems involving vertical projectile motion, right? So let's just get straight into it. So let us first define what we mean when we talk about projectile motion, or when we talk about a projectile. So you need to understand that a projectile is an object that moves freely only under the influence of gravity alone, or gravitational force. And when that happens, we say that an object is in free fall. So imagine if you have a feather, you drop it. From the moment you drop it, maybe at a particular height, because you're holding it up until it reaches the ground somewhere, we will say that that feather is free falling, or it is a projectile, because during that time it is only moving under the influence of gravity only. So that's what we mean. So we will say the object is in free fall because the only force that is acting on that object is gravity. Hence, it is actually falling down. So it's important for you to understand this definition when we talk about a projectile. And for now, we will only consider a vertical projectile motion, right? In one dimension. So that is either up or down. And a few things to note about vertical projectile motion, or free falling bodies, is the first thing is that the gravitational force that is exerted by the Earth is the only force that is acting on this body that we said is in a free fall. There is no other force. In most instances, in all instances, actually, we ignore the effects for now. We ignore the effects of air resistance. The second thing is that gravitational force always acts downwards. This is important when we talk about gravitational acceleration, that small letter g, which has the value of 9.8 meters per second squared. It will always be down. So the reason why when you throw an object up and then it comes down is because of the gravitational force, because it is pulling it towards the center of the earth, right? The number 3, a projectile that is moving upwards will slow down. This is very interesting. Let's say you throw a ball upwards. Its velocity, when it's going up, the velocity decreases up until it reaches a velocity of 0, stops there momentarily at the maximum height, then begins falling down. And when it's falling down, when this projectile is now moving down, the speed will increase. So it will move from being 0 and then it will start increasing. The only difference in this will be the direction. So when it's going up, maybe we'll say it's positive. When it's going down, it's negative, right? But this is important. When an object is moving up, you must understand this: the velocity will decrease until it reaches 0. Hence, it says when it moves upwards, it will slow down. And now when it's moving down, so it decreases up until it, let's say you release your object, you project something at a velocity of 5. So it will be 5, 4, 3, 2, 1, 0. Stops momentarily, then comes down. Then you have 1, 2, 3, 4, 5. Up until, it depends how far your object will go, right? And for now, we're considering vertical movement. Hence, our topic is vertical projectile motion, right? So that is your up and down, right? Is considered. We will not be taking into consideration the left or the right, right? Cool. So before we go into solving problems, we need to understand this thing. I've already mentioned it. So when we say an object is in free fall and it's near the surface of the earth, it experiences acceleration, and that acceleration will be due to gravity. So its velocity will change as maybe when it moves up or down due to gravity. Remember, all free falling bodies are only under the influence of gravity, right? And this acceleration due to this gravity is found to be 9.8 meters per second squared, and is always down. And this is very interesting because if you take a feather and maybe an apple, and then you drop them at the same height, so maybe you drop them at the same height, you're holding them on both hands, right? And then you drop them, they will actually reach the ground at the same time. And this is because going downwards, they will be experiencing the same acceleration, because they will be in free fall, and that is if we ignore the effects of air resistance. So now just look at this animation over here. So you see that we have can you imagine this as a ball? So say you kick a ball and then it goes up, then it starts falling down. At some point, you see, we would look at three of them. There's a number of them, you see. So let us look. We had a ball that went there, you kick it, gets high, it will have to come down. It can't go up forever, and then it starts moving down, right? And you see it forms this sort of a parabolic type of motion. And here at the maximum height, so this is the maximum height it can reach before it comes down. And then we have a different ball that you kick. Maybe you're kicking it faster, its maximum height will be here before it drops down. But also when you maybe kick a ball just up, straight up, it will go up, right? And then at some point it will reach a velocity of 0, and then it will start going down again. All of those scenarios represent vertical projectile motion, right? Because the moment the ball, maybe we took an example where you kick in the ball, the moment you do that, it has left your feet. It's now a projectile, or the object is in free fall, and the only force that is acting upon it is gravity. There is no other force when we ignore the effects of air resistance, right? Let me just play this again so that you can see. So if we were to draw the position time graph of projectiles, this is normally what they would look like. So this will be an example of an object that is projected, right? You see that one, is just went vertically up. Okay. Another type of object you can look at is maybe you are playing basketball. So there you are, you throw it. So when something is thrown upwards, we'll say that is a projectile. It's projected or it's thrown upwards. It experiences free fall, right? So there you are, you throw a basketball, then it goes up. Maybe you launched it, you projected it, or you threw it at a certain velocity. It goes up, up, and it reaches the maximum height that it can possibly undergo. And then there at the maximum height, it will stop momentarily. Then it starts going down again, down, and then of course now you're gonna make the shot, right? So that is very interesting if you think about it. Another type of you can look at another example where you just shooting something. You see just now you shoot it, there it goes first up momentarily, there the maximum height it stops, then it goes down. So there are different types of projectile motion that we can look at. I'm not going to talk about everything, but all the examples that we have discussed should give you a clue of what is it that I am talking about, right? Another example is when you drop something. We spoke earlier about when you drop a feather and an apple, at the same height and they will reach the ground at the same time. When you drop it during that motion on its way down to the ground, this tennis ball will be in free fall, and we can represent its motion using your position time graph, where you see that it is actually a projectile, right? Wonderful. Let's see. So when we solve, the quality of this is not nice, I apologize for that. When we talk about free fall, when we talk about vertical projectile motion, we make use of equations of motion in the vertical direction. Remember, in grade 10 you were introduced to equations of motion. These equations on your screen should look familiar. And if you have a question paper or a formula sheet, you can look them at the back of your question paper and you'll find them. The only difference here is that here we have a change in y, because we are considering the up and down motion, so the vertical motion. So that's the only another difference is that here we have g, which is gravitational acceleration, instead of having your normal acceleration, which is represented by a. So you need to know how to use these equations of motion. You need to know them. They are given to you at the back of your question paper, but it's important for you to know them by head and to know how to use them. So a change in y is just the displacement. So a change in y, and then vi is the initial velocity, vf is the final velocity, change in t is the change in time. So how long was that motion, right? We've already spoken about g, which she said is the gravitational acceleration, and you know its value is 9.8 meters per second, right? I think we've talked about everything here. So it's very important. Look at them and understand how to use them. So when we solve problems of vertical projectile motion, I like to draw a sketch diagram of what is described to me. Then I'm gonna write down what is given. So maybe you're given the initial velocity, or you're given the final velocity, or you are given the time. So you write down what is already given to you, so that you know exactly what is it that you need to solve. Another important thing is for you to choose which direction is positive. So someone might say, I will say upward motion is positive, and then that would mean that downward motion will be negative. Let me go back. Will be negative, right? Or someone might say, I choose downward motion to be positive and upward motion to be what did I say? I choose downward motion to be positive and upward motion to be negative. It doesn't matter, but it's very important for you to keep that same convention throughout all of your question. You can now solve question 3.1, where you said up was positive, down was negative. Then when you go to 3.2, you say down is now positive. You will get your answers wrong, right? And then the next step will be then how to solve now, right? Another important thing before we go, I show you guys how to solve these types of problems, is to understand a few things about projectiles. So the first thing we'll talk about is the time symmetry. So when we talk about this, is that you saw the type of movement when you draw your position time graph of an object in free fall or a projectile. It will most likely look something like this. So this looks like a parabola, parabolic motion if you look at it from mathematics, right? So let's say you kick your ball, and then there it goes up, up. So let's say this is the time scale. On your x-axis is your time scale, and then here it's your position. So you kick your ball there at 0 seconds, 0 meters. After a couple of seconds, your ball will be somewhere there. After a couple of seconds, you see it's somewhere there. And then it will finally reach a maximum height after a number of seconds there. And there, the maximum height, its velocity is 0. Then it will start traveling down, you see. Then here it reaches the same point at which it was released, right? So what is important that you need to know? You need to understand the time it takes for it to go from the point where it is released up until the maximum height is equal to the time it takes for it to fall from the maximum height till the point of release. It's a very important thing for you to understand because it will help you solve the problem, right? I hope that is clear. Another thing we can look at is the magnitude of the velocity. So let's say you launch your ball here at a velocity of 5 meters per second, right? And then it goes up, reaches a velocity of 0, then comes traveling down. When it passes the same point on its way back, it will have the same velocity as was the initial velocity. It means when your object is here on its way up, let's say here it was experiencing a velocity of 2 meters per second. Even on this side, when it passes the same point, the same height, it will also experience the same velocity. The only difference would be the direction. So here it will be maybe positive. If we chose upward motion as positive, so positive 2 meters per second, and then on the other side we'll have negative 2 meters per second. So those are nice things to know. It's important for you to know so that when you are solving, you understand those types of graphs, right? So now we're going to look at a few examples and I'm going to show you how to solve them, right? So the first example that we will be looking at, let us read the question on the screen. So we have an object which is projected vertically upwards. So you can imagine if you just project or throw an object upwards, right? It goes up, so from your hand it will go up, and then it reaches a certain height, it will come down. But this object, this particular object that they are talking about here, it is 4 seconds later, it is caught at the same height, the point of release on its way downwards. So this person maybe projected the object up, then the object started falling down again. When it fell down, it was caught. And now we have to determine how long it took the ball to pass a height of 8 meters in the upward direction. And I'll just show you now how to actually go about solving this type of problem. It's very interesting. We have an object that is vertically projected upwards. So imagine if you were holding a ball and you threw it upward. So to do that, the first thing you need to do is to draw a time position graph. So say on the y-axis we have the position, we call that y, and it's measured in meters, right? And then on your x-axis, then you have your time. So it's gonna be t, which is measured in seconds. Okay, so if we were to draw the motion of this object that is vertically projected upward, we would say it starts from at 0 seconds there, or 0 meters even. So let's say it starts off at 0 meters and it's projected upwards. It goes up until it reaches a certain maximum height. So let me just get a pen. It will just go up until it reaches a certain maximum height, then travel down again, right? So here at this point, we can say maybe on the y-axis that would be the maximum height. Let's say h max, right? So they say the total time it takes for it from the point of release here to also reach the same point on its way downward is 4 seconds. It's 4 seconds. And we know that because of that time symmetry, the time it takes for it to go up is the same time it takes for it to go down. So from 0 to 2 seconds, it's going up. So in this point, your ball is actually just going up, or your object, they said it's an object, it's going up. Let me just remove that. So it's going up. It's on its upward motion here. And the time it takes is 2 seconds. And then here, it's going down. So what is important to understand is here at the maximum height, its velocity is 0. So v equals to 0, 0 meters per second. No, the handwriting looks terrible. Okay, so we can say to solve this problem, we can just label there at the start, label that point A. At the maximum height, let's call that point B. And then when it reaches the same point of release on its way down, let's call that point C. Right? And now our question wants us to find the time it takes the ball on its way up. So when the ball is going up, after how long does it reach a height of 8 meters on its way up? And to do that, we can use our equations of motion that we spoke about. So there's 4. So there's 2 that you can pick from. And we're going to use this one where the change in y is going to be equals to v initial. And already realizing, but we don't have the initial velocity or the final velocity of the ball here. We don't have the initial at the end of the motion, but we don't have the initial velocity. But we can find this initial velocity here. So vi, you'll see how we find it. So vi multiplied by a change in t plus a half g change in t. So our first task is to find vi, right? So how do we do that? We also use our equation of motion. So we can say, okay, vf, this is the one that we're going to use, final velocity, equals to vi plus g change in t, right? So we have to find vi, that's what we're looking for. But you may ask, what's vf? So if we only consider the motion between A and B, only when the object is going up, we can just say between A to B. There are a few things that we know. We know the time from A to B is 2 seconds, so we have that. We know g, that's our gravitational acceleration, is 9.8. And since it's acting downwards, right? And before we do that, it's important for us to decide that, okay, let's say up is positive, and then downward motion will be negative. So it's always very important for you to decide the direction early on. So positive and negative for down. So meaning the g, because it's always acting downwards, is going to be negative 9.8. And then vf, so the velocity here at b, because we're only considering a to b, will be our final velocity, right? So our vf, we know there the maximum height, we said it is 0. So we already have that. So we have 0 equals to vi, that's what we are trying to find, plus g is always acting down, so we said down is negative. So it meaning that we're going to have negative 9.8. Multiply the time from A to B, it's 2 seconds. and then can just say 0 will then be equals to vi. So if you put that in your calculator, negative 9.8 times 2, you're gonna get a negative 19.6. You can just check that that is the correct value that you get. So you have 19.6. But then we can say, okay, let's just take 19.6 to the other side of the equal sign. And when you do that, you know that from algebra, the sign is going to change. It's going to be now positive. So when it's this side, it's going to be 19, positive 19.6, 19.6, which is equals to VI. So we know that this is, you're not done here. You also need to show the units. So we know that velocity. So this is telling us that the initial velocity, the object is projected at a velocity of 19. It's positive of 19.6 meters per second because the value we get is positive, it means that it's going up, and we know that is true because they said that your object is launched up, it's projected upwards. So when we have this, it means that we can take this value vi and just somewhere substitute it there, and then we know we'll just be looking for the change in time because we already know what g is, right? So our next step will be just to do that. So it means that this equation is going to look something like this. So it meaning that, so the change in y, they're saying at a height of 8 meters, so that will be our change in y on its way up. So meaning our change in y is going to be positive because we decided that up is positive. So it means that we're going to have 8, right, equals to, we have vi. They said it's 19.6, and then the change in t we don't know. That's what we're trying to find out. So you can just write there a placeholder t. So it's 19.6 t plus a half multiplied by g, our gravitational acceleration. No, it's a constant value. Its value is 9.8, right? So that's 9.8. But because it's always acting downwards, and you said downward motion is negative, we need to put a negative there. Then multiply by changing t. That's what we're trying to find out. Okay, here is just a matter of maths, algebra. So you have 19.6 t so 19.6 t plus, so a half multiplied by 9.8. That's, if you put that in your calculator, you're gonna get a negative 4 point, let me check, it's 4.9. So a negative 4.9 t. And if you look at this, you can already tell it looks like a quadratic equation. If it's not clear, let's just take everything to one side. So let's just take everything to the left hand side and leave 0 on the other side. So if we do that, we can have, remember the negative for 4.9, so this is t squared. Forgot to add the t squared there. It's t squared. So if we do that, it means that we have negative, it's going to the other side, it's going to be positive. So we have 4.9 t, 4.9 t squared. And then this one, it's positive, when it goes to the other side, it's just going to become negative 19.6. So other side of the equal sign, 19.6 t plus, remember on the other side of the equal sign there's this 8 plus 8. And if you've taken everything from the right hand side, it means there is 0 left. And if you look at this, you will notice that this whole thing was a mistake. I'm just trying to erase that. So this is okay. So if you look at this looks like the quadratic equation, right? Because we have a value of 4.9 t squared. So we have 4.9 t squared. So that's 4.9 minus 19.6 t, right, plus 8, and all of it is equals to 0. So if you go back to mathematics, remember we have that quadratic equation where it says ax squared plus bx squared, no, plus bx, I'm lying, plus bx plus c equals to 0. And one of the ways of solving this equation is to use the quadratic formula. So if we were solving for this, we would use this formula over here. So we would say it is x equals to minus b plus or minus a square root of b squared minus 4ac, 4ac, and all of it is divided by 2a. So that's a there, right? So but now the only difference here is that here our variable is t and here it's x. So it means that to solve for t, we can just write that t will be given by t will be equals to minus b plus or minus so that's a square root plus or minus b squared minus 4ac, 4ac, and the whole thing will divide by 2a. And now maybe the question you may be wondering, what is a, b, and c? So we will look, our a, we will see that in this equation over here, our a is 4.9. So we say a is going to be equals to 4.9. A is going to be equals to 4.9. Our b, if you compare these two equations, so you see that b is the coefficient. So b is going to be that coefficient of t, which is negative 19.6, and c is just this value there, 8. Then we say c is equals to 8, right? And then here it's just a matter of substituting a, b, and c into this equation. So you'll know that you're going to have two equations. So you're going to have t, because remember it's a quadratic equation. It means that you're going to have two solutions for t. So you have a solution where we say minus b, and we know our b is negative 19.6. So you put negative 19.6 in your brackets. It's very important for you to enter this correctly into your calculator. Otherwise, you're going to get the wrong value, right? And then it's plus or minus. So for the first one, you say it's plus, and then you say that whole thing is going to be in a square root b squared. So we said b is negative 19.6. So you have that negative 19.6, and all of it is squared, minus 4. What's our A? Our A is 4.9. And then finally the whole thing is multiplied by C. Our C is 8. Remember, this is under a square root, and the whole thing is divided by 2A. And you say 2, what's our A? Our A is 4.9, positive 4.9. And you just need, the only thing you need to do here is to put this in your calculator with all the brackets. Then you will get a value of 3.54. 3.54 seconds. So that will be our first solution, 3.54 seconds. Right? So we need to check the second solution. So the second solution, we do the same thing. We say T is going to be equals to negative B, so that's negative. Then you open a bracket, you say negative 19.6. Right? And then previously we had said that a plus there, so now we say the negative. Then you open a square root, then you say b squared, it's going to be negative 19.6, all of it which is squared, minus 4a. Our a is 4 point, let's check, our a is 4.9, if I'm not mistaken. Why can't I see it? Our a is 4.9. So our a is 4.9. You write it down. Okay. So we need to write the 4.9 in the brackets. So we have 4.9, and our C is just 8. And all of this is under a square root, and the whole thing is just divided by 2a. So 2, what's the value of our a? It is 4.9. If you put this in your calculator the way it is, it should give you a value of 0.46. So 0.46 seconds. Small letter s means it's in seconds. So you see, we have two solutions. We have t when it is equals to 3.54 seconds, or t when t equals to this value over there, 0.46 seconds. So we have two values of t. But you need to understand what the question asked us. The question said that the height, the time it takes for the object to pass a height of 8 meters on its way up. So what do we know about our motion? We know that the time it takes for the whole for the motion up is just 2 seconds. Remember, for it to reach the maximum height before it starts now traveling back down, it's just about 2 seconds. So this value cannot be true, because at this time our ball will now be traveling down, meaning the right solution would be there, t equals to 0.46 seconds, and you would have essentially managed to solve your that question. Another type of question we can look at is this one. So a hot air balloon ascends. That means that it's going up, it's moving vertically upwards, right? With a constant velocity of 5 meters per second. A ball is dropped from the hot air balloon at a height of 50 meters and falls vertically towards the ground. So that is the question. So let us just look at this. So you have your hot air balloon. This is a hot air balloon, and how it works is that so the first thing you have to know is that hot air is lighter than cool air. So the air inside the balloon is heated, and as a result the surrounding air is cool. That means that the hot air will actually rise because it's much lighter than cool air. That's basically the basic principle of how a hot air balloon works. You can read up about it online. So there is a hot air balloon, it's going up, and then somewhere after it has reached a height of 50 from the ground, a ball is dropped down. The ball is in projectile motion because the only force acting on the ball after being released is your gravitation or gravity. However, the hot air balloon, is very important for you to understand, is not in it's not in free fall because there are other factors, there are other forces. For the hot air balloon, we actually have to consider yes, there is gravity, but also have to consider the weight or air resistance because the whole thing operates by heating the air inside the balloon, and hot air, as it is lighter than cool air, it will essentially just rise. I hope that is clear. So you look at the forces that are acting on the air. On the hot air balloon, we can check your gravity. The wind is also exerting some force on the hot air balloon, as well as we have to consider air resistance, right? And they said to us that the hot air balloon is moving vertically up at a constant velocity of 5 meters per second, right? The ball, on the other hand, after it has been released, there's only a single force that we have to consider, and that is gravity. That means that our ball is in actual fact in free fall. So that will become important, clear why I'm mentioning that. Be cognizant, be aware of the fact that the hot air balloon is not in free fall, only the ball is in free fall as it moves down, right? And then the first question we will answer is this one. Question A says determine the distance between the hot air balloon and the ball after 2 seconds. So that's what we have to do. So after 2 seconds, it means the ball will be at a much higher distance than it is now. It was 50 meters. Maybe it will be at 65 or 70. We don't know. We're going to calculate. And the ball will also have, maybe, remember, it started off at 50 and then it's dropping down. And then that distance, the difference in that distance will tell us how far apart are the two objects now. So let's actually do that. Let's solve this problem. So let us now try to solve this question on the hot air balloon where a ball is dropped, right? So remember, you have a hot air balloon that is moving up, that is traveling at a constant velocity up, and they said that constant velocity is 5 meters per second, and it's going up. So you can just say up or upwards. And then on the other hand, a ball is being dropped, so that ball was dropped and it's traveling down. We don't know the velocity of that ball at the instant, but we're looking for that distance there between the two after 2 seconds. So we're gonna calculate the distance, this distance here after how long? 2 seconds. So to do that, it means we have to first find the distance that the hot air balloon has traveled on its way up, then find the distance that the ball has traveled on its way down, and then after that we take just the difference between the two, and it will actually give us the distance between these two objects after that 2 seconds. So let us do that. Find the distance the hot air balloon has traveled up in 2 seconds. So to do that, we just say, okay, what is it that we have? We know that we have VI for the hot air balloon, right? Which is 5 meters per second. So 5 meters per second, right? And another important thing is that for you need to decide the direction. So I'm gonna say up is positive, and then I'm gonna say down is negative, right? And then what else do we have? We also have the change in t, which is the time. So they said after how long? After 2 seconds. So after 2 seconds, right? What else do we have? We also have g, right? We know that to be 9.8 meters per second squared. Meters per second squared, right? And it's going down. So if it's going down, it's going to be a negative. But then, is this important for the hot air balloon? This is actually not important. Why? Because we've already spoken that the hot air balloon is actually not under free fall motion, because there's a force that is pushing it upwards, right? So remember how a hot air balloon works is that the warm air is lighter than the cold air. So as the air is heated in the hot air balloon, it will rise, and there are a number of forces that are actually acting on the hot air balloon, pushing it up. So in that case, we actually don't need to, it's not a free fall motion, so it's not only under gravitational acceleration. So you need to also actually find its acceleration, and to do that, you know that the form acceleration is just the change in velocity. So we say, okay, VF minus VI, and all of it divided by a change in time, right? And then we say, okay, what is our final velocity for the hot air balloon? Remember, it's moving up at a 5 meters per second at a constant. So they said it's constant, meaning even after at 2 seconds, it's still moving up at 5 meters per second upwards, right? So it's a constant. So it means we'll have 5, even its initial velocity is 5, and the whole thing is just divided by 2, because that's the time that has elapsed. And then 5 minus 5 is 0, divided by 2 is 0, meaning its acceleration up is 0 meters per second squared. So I feel like I need to mention this again. The hot air balloon is not in free fall. Only the ball is in free fall motion, because there are other forces. In terms of the hot air balloon, we have to consider the air resistance, so which is a force. So that air resistance together with the gravitational force, meaning that your object is no longer in free fall, right? Only this ball is in free fall, and only then can we say we would use G. But for the hot air balloon, you don't need to use G. You actually have to find that acceleration. So you see that if an object is moving at a constant velocity, it's actually not accelerating, hence its acceleration will just be 0, right? So let's see, you look at the equation, you look at an equation there, because we're trying to find change in y, right? You look at the true equation and you say, okay, which equation allows me to substitute vi, initial velocity, allows me to substitute the change in time, right? Also allows me to substitute the acceleration, and then you'll see, oh, okay, it means that I can just say change in y equals to our initial velocity multiplied by a change in t plus a half, and we don't put g there, we say a, because it's not the hot air balloon is not in free fall, right? T squared. And then you say, okay, what's my initial velocity? So okay, my initial velocity is 5 up, so it's positive because we decided that upward motion is positive. The change in time is 2 plus a half, so it's a half. What's our acceleration? Is 0, so it's multiplied by 0. What's our change in time? It's 2, and that 2 is going to be squared, so that's 2 squared over there, right? And then 5 times 2, we know that is 10, so it's 10, it's distance, so it's 10 meters. So it meaning that in 2 seconds the hot air balloon has traveled a distance of 10 meters. So just remember here, a half times 0 is 0 times this is 0, so this whole thing is just going to be equals to 0. Hence your change in y is going to be 10. So remember, when the ball was dropped, that hot air balloon was at a distance of 50. So it was somewhere, let's say it was at 50 meters. And then after 2 seconds, as we've calculated, it's now at 60. So it's at 60 meters. Now we have to find the distance that the ball has traveled after 2 seconds. So let's just do that. So first of all, we need to see what is it that we have. We know that the initial velocity of the ball, is, because remember, before the ball is dropped, the ball and the hot air balloon are both traveling at a constant speed of 5 meters per second, and they are both going up. So this also is the initial velocity of the ball. It's up, right? So it means it's going to be positive. So like we said, upward motion is positive. This is the thing with physics, especially in terms of vectors. You just need to select the direction and say, okay, if up is positive, down is negative. Or somebody can say up is negative, down is positive. You're still gonna get the same answer as long as you make sure that you continue that. So in the middle, you don't just now change and say now all of a sudden up is negative and down is positive. It has to be the same throughout the entire question, right? So we said we have the initial velocity. We also have g now, because remember, for the ball is in free fall. The only force that is acting on that ball is gravity, so it is in free fall. So here g is applicable. So we have g, which is our gravitational acceleration, and it's given by 9.8. And remember, g is always acting downwards, gravity is always acting down. So it meaning that this value over there is actually going to be negative, because we said down is negative. So you have a negative 9.8. What else do we have? We also have a change in t, because they said that the time, where is the ball after how long? After 2 seconds. So that would be your 2 seconds. And we say, okay, you look at your equation, you're trying to find change in y, and you select an appropriate equation there. So you say, okay, I have vi, it means that I can use this equation. I can say vi, a change in t, plus a half. So you see, it's the same equation that we used previously. The only difference now is that here, instead of axle A, we're using g for the acceleration. Change in t squared, right? So you say, okay, what's my initial velocity? My initial velocity is 5 upwards, so it's positive, because we decided that upward is positive. The change in t is just 2 seconds, plus a half. Our g there is going to be negative, so you're going to put negative 9.8. Negative 9.8. So negative 9.8, and then the 2 there is going to be in brackets. And you can just put this in your calculator. And if you do that, you're going to get, okay, I forgot a negative 9.8 there. If you put this in your calculator, remembering all the brackets, you should get a value of negative 9.6. So it's negative 9.6 meters. So what does that mean? It means that the ball has traveled 9.6 meters down because of this negative over there, because we said negative is down, it means down, right? So let's just draw this sketch over there. So you said the ball was dropped at 50 meters. The ball was dropped there at 50 meters, and we calculated that after 2 seconds the hot air balloon is at 60 meters, right? So this is the balloon, and then now they're saying that the ball, after 2 seconds, it has traveled a distance of 9.6. It means that the ball after 2 seconds is now at 40, because it's just going to be 50 minus 9.6. It's at 40.4 meters. So this is the ball now, position of the ball. And now we're trying to find the difference, this difference here. And that would actually be the distance between the two objects after 2 seconds. So you can just say it's going to be 60 minus 40.4. 60 minus 40.4. And if you put that in your calculator, it's going to give you a value of 19.6. 19.6 meters. Of course, there are many ways to solve for this, but for me that was one of the simplest way. So this, what does this mean? It means that the distance between, so you write down, therefore the distance between so write it fully, between the hot air balloon, you write the entire thing, hot air balloon, and the ball is 19.6 meters. So that's what you need to write down. It's going to be 19.6, so it's going to be that value over there, right? And yeah, for the first part of the question, you are done. So the follow-up question on that hot air balloon with a ball that is being dropped is this one. where we said we are told that we need to determine the velocity of the ball when it reaches the ground. So you have a ball that was initially released at 50 meters and then it's dropped. Remember, we also know the initial velocity, it was 5 meters per second if I'm not mistaken. And then it's dropped. When it reaches the ground, we will have to find its final velocity there. And I'll just show you guys how to go about solving that type of problem. The next question requires us to determine the velocity of the ball after it has reached the ground. So remember, the ball is released at 50 meters as we've mentioned. So that's 50 meters above ground. It means when it reaches the ground, it has traveled a distance of 50. So its change in y is going to be 50. And because we've decided down, so that's the displacement, down is negative and up is positive. It means that the change in y is actually going to be negative because it's moving down. It's going to be negative 50 meters. Right? Okay. So what else do we know about the ball? We know that its initial velocity was 5. It was 5 meters per second, and it was going up. Remember, when the hot air balloon, before the ball is dropped, both of them are moving at this velocity and they're all moving up, right? And what else do we know? We know that we also know g, and g is also downwards, so it's going to be a negative of 9.8. It's a constant. You'll be given this value at the back of your question paper, so there's no need to calculate this value. Is 9.8 meters per second. Okay, so now we have to look at our 4 equations of motion and look at an equation that you can use, which will require you to use the change in y, the initial velocity, plus the g. There's many ways to do this, but for me the simplest one would be this one, where we're saying that vf squared equals to vi squared, so that's the initial velocity, plus 2g change in y. So that will be your change in y, right? And then I know to find vf, I have to say put the entire thing in a square root. So I can just already put this in a square root. We have vi squared plus 2g, a change in y, right? And then now it's just a matter of substitution. So you put this, everything in a square root. So you say initial velocity, we said it's 5. The ball was going up initially at a velocity of 5 meters per second. Then it's dropped. So that is initial velocity. Plus 2, we said that gravitational acceleration is a negative of 9.8. We've already explained why it's negative. And then the distance it travels, it's 50 meters because it's dropped at a height of 50 meters. It's 50, so its displacement is just going to be negative 50, right? And then you put this in your calculator, you're going to get a value of, remember, whenever you put something under a square root, the answer will be plus or minus. So you're going to have plus or minus 31.70. So it's going to be 31.70 So you write it 2 decimal places, 0 meters per second. But we're not done. So you know that your ball is moving down. So its final velocity will be down. And we said down is negative. So meaning the actual answer, so therefore the actual answer will be VF equals to negative 31 point or comma 7 meters per second. Meters per second. Or you can just say it's 31 comma 7 meters per second down. And then after that you'll be done with this equation. Next we're going to look at an example or a question from a previous exam. So let us now look at a typical exam question. I took a screenshot of this on my phone and I'm realizing that the quality is bad. I'll need to find exam question papers, but that's not important. I'm hoping that you can clearly see on your screen, right? So let's read. It's question 3 and it says that a ball of mass 0.5 kg is projected vertically downwards. So it's projected down, it's going down towards the ground from a height of 1.8 meters at a velocity of 2 meters per second. So this is the initial height where your mass, your ball is, and then it's gonna go down at the ground. And we are given the position time graph for the motion of the ball below. So on your y-axis you have your position measured in meters. So that means where is your ball at that particular instance, right? Then here you have your time in seconds, given time t1, t2, t3, t4 up until t5, right? So what's happening here? You see there between t1 and t2 as well as between t3 and t4. When you see this type of graph, position time graph, what that is telling you is that yes, this ball is gonna bounce. So your ball is dropped there, right? Projected vertically downwards. It goes down, boom, and then it will come back up again. But when it comes back, it's not gonna reach the same maximum height. On the first bounce, it goes up, it reaches this maximum height of 0.9 meters. Then it could go down again. Here, it's in contact with the ground for a couple of seconds, then bounces back up. Imagine if you take a tennis, you throw it down, you project it vertically downwards, boom, and then it bounces. It's in contact with the ground for a few seconds. Those seconds may be so small that you're not able to see, or you think that it's almost immediate. It goes down again and bounces for the second time, then finally here at t5 it stops, right? So let's see what the questions are like. So the first question is, what is the maximum vertical height reached by the ball after the second bounce? So we know it's projected, hits the ground. This is the first bounce, this is the second bounce. So the maximum height reached will be here, meaning that it will be in contact with the floor and then it bounces back up and it reaches that maximum height of 0.5 meters. So that would just be your answer for question 3.1. So this means that you need to be able to interpret these types of graphs in general. You need to be able to interpret them and be able to take information from them and use it. So it's just 1 mark, it's just a matter of analysis. Question 3.2 requires us to calculate the magnitude of time t1 indicated on the graph. So let's see how we would go about solving that particular problem. In question 3.2, we need to find the magnitude of the time t1 on the graph. Okay, so and that whole question is worth 5 marks. So it means that you'll need to work extensively. So first things first, let us draw that position time graph that was given to us. So say this is the x-axis, the y-axis, right? And this will be your x-axis. I know it looks terrible, but that's not the point. And then you have a ball that is dropped at a height of 1.8. So let's say 1.8 was somewhere here. It's in meters, right? And that ball was dropped. It goes down, hits the ground after a time given on the graph is t1. So that's what we're concerning ourselves with for now. So we would say, okay, we are looking for the time t1, which we don't know what it is. And then the second thing that we're looking at, okay, so we need to write down what is it that we know. But before we do that, it's important for you to decide your direction. So I'm going to say, okay, down is going to be negative, and then up is going to be positive, right? So it's always important for you to decide this early on and keep it throughout your specific question, right? So that's what I'm deciding. So what is it that I know about this? Is it a ball or a ball of this ball? I know that it was released from a height of so it's from a height of 1.8, and it's moving down, right? So I'm gonna say it moves down from 1.8 up until the ground. So the ground is gonna be, let's say it's gonna be 0 meters, right? So it's gonna be 1.8 meters. It's just 1.8 meters. I almost wrote 1.8 meters per second. So our displacement there is going to just be 1.8 meters. 1.8 meters, and it's down. If it's down, it means that it's going to be negative, right? Cool, because this is displacement, and remember, displacement is a vector, so you must show the direction. The other thing that we know is that it was released at it was projected. That's the key term. That it was projected at an initial velocity of 2 meters per second. It's 2 meters per second. It's down because it's projected vertically downwards, so it's negative, right? What's the other thing that you know? So that will be your gravitational acceleration. We know this is a constant, is going to be negative 9.8. Is always acting downward. So since we selected down as negative, it's going to be negative 9.8. If somebody else might have selected down as positive, so that value will be positive. So that's just one of those few things that you need to understand, right? And then you're like, oh, okay. So I'm looking for the final for the time. So the time that after how long does the ball hit the ground? And I don't have the time. And then you check, do I have the final velocity of the ball? So do you know the final velocity? The answer is that we don't know the final velocity. And the first thing you need to do is say, oh, okay, I can find the final velocity, and then if I have both the final velocity and the initial velocity, I should be able to calculate the time very easily. So now our first task is to find that final velocity. So you're gonna look at an equation that will allow you to use initial velocity g as well as the position, and that equation would then be vf squared, which is equals to vi squared, right? I'm a bit distracted, I apologize. Vi squared and 2 g change in y. Like I said, there are many ways of doing this. You don't have to use this formula, but for me it's the easiest. right? So you say okay, and then you're trying to solve for VF. So if you solve for VF, and then you can say, oh, okay, what's my VI? So you know VI is a -2, a -2 squared plus 2. Our 9.8 is also going to be negative because down is negative. Ooh, it's very difficult to write using this thing. Okay, let me just erase that entire thing. Cool. So it's going to be 2 G. My G, I have to be very slow. But that's a good thing because then you are able to follow me quite easily, right? It's going to be 9.8. Change in Y is going to be 1.8 because the ball traveled a distance of 1.8 meters down before it hit the ground. So it's just a matter of putting all of this in a calculator. So if you do that, so in VF is going to be, so remember the square root there. So find the value there that you get there, you put it in a square root. So if you put this entire expression in a calculator, you're gonna find something like 30. Ooh, can't see where I've written this down now. I think it's 39.28. So you say it's 39.28, right? It's just this expression that you calculated over there. And to remove this square on this side, you introduce a square root. And the answer will be plus or minus 6.27. Plus or minus 6.27. So it's important for the answer that you get on your calculator, you need to be able to round it off correctly. 6.27 meters per second. But we know that our ball is being projected downwards. It's going down. It meaning that final velocity would actually be a negative because we decided that down is negative. So this is the velocity with which the ball hits the ground with. It's a negative 6.27. Negative 6.27 meters per second. And that essentially just means that it's 6.27 down. So VF, so you can say therefore the final velocity of that ball, the velocity that the ball hit the ground with was 6.27 meters per second. Meters per second, and it was going down or downwards. So I put an emphasis on direction a lot because a lot of students struggle, especially with vectors. If something is a scalar quantity, you can just report the value that you get. But if it's a vector quantity, it's often important, unless the question says you shouldn't, for you to include the direction. But you're not done. So now we have VF. So now we have VF, right? Let me just remove this. So now we have VF, and the value of it is 6. So we just calculated it. It's 6.27. 6.27 meters per second. And because it's going down, your object is being projected down, it's going to be a negative. And now we need to find the time t. Even with this, because you have now a number of values, a number of things you can use. You can pick either one of the equation, but I always say I prefer to use the simplest. So you find an equation that can include VF, VI, and G. And the simplest equation that can do that is our famous equation where we say, okay, I don't like this pen. Let me pick a red one. It's VF. So you have VF equals to VI. Like, this is the simplest, right? Equals to VI plus G, a change in T. G, a change in T. And then we say, okay, what's my VI? My VF. I know my VF is going to be negative 6,27, negative 6,27, which is equals to my initial velocity. My initial velocity is going to be negative 2. What's going to be G? My G is going to be, which your gravitational acceleration is going to be a negative of 9.8. So that's 9,8. And then our change in time, remember we are looking for T1. So you can just write T1 there. Even with this equation, there's a multiple ways of solving it, right? So okay, you can say I can just take this to the other side. So you have a negative 6.27. From here now, it's more of maths than it is physics. And then this 2, when it goes to the other side of the equal sign, it becomes positive. So you have plus 2. And then on this side, we have a negative 9.8. 9.8 T1. So how do we make T1 subject of the formula? Because the operation between 9.8 and T1 is a multiplication. To get rid of that 9.8, we need to divide by the negative 9.8. So negative 9.8 divided by a negative 9.8 is going to be 1. It's almost like we're going to cancel the 2. So you divide both sides by a negative 9.8. Negative 9.8. So when you do that, so you say, yeah, you are cancelling the 2. It's just a matter of dividing and you get a 1. And then you, on this side, you're left with T1. And then you put this whole thing in your calculator and you should get, I'm going to pause this a little bit. And the answer that you will get is going to be positive 0,44. So what does this mean? It means that your ball was released at that height of 1.8. Oh, was released at that height of 1.8 at 1,8. It's released, hits the ground. It hit the ground after 0.44 seconds. Right? So that will be the value of T1. That point there, T1. And this type of motion that we see, it hits the ground, it's in contact with the floor, and then it bounces up again. It means your ball that is bouncing. But that's what we needed to do for question 3.2. I think then we can move on to the next question. Let us now look at question 3.3, which says velocity. You have to calculate the velocity with which the ball rebounds from the ground during the first bounce, and that is a total of 4 marks. So I'm going to show you just shortly how to go about solving that type of problem. Okay, so we need to find the velocity with which the ball rebounds from the ground during the first bounce. So you have a graph like this. This is the x and y axis. So the ball drops, hits the ground. it hits the ground after 0.44 seconds. We've calculated that in the previous question, and that's your time t1, right? And then it's in contact with the ground for a while, then it goes back up, and then when it goes back up, it reaches a maximum height of here, a maximum height of about 0.9. So you say there, you just draw dotted lines. You see that height there is about 0.9. Looking at the sketch that was given to us, right? So now they're saying they want the velocity with which the ball rebounds from the ground. So when this ball, after it's in contact with the ground for whatever time it is, what is the velocity here when it leaves the ground on its way back, right? So let's just, it means that we only concern ourselves with this part of the graph, this part from there to there. Okay, no, let me erase that. So we need to only concern ourselves with this part there from 0.44 seconds up until the maximum height there of 0.9. Okay, and then we will say, okay, what is it that we know from here to here? We know first, the first thing we know is that the velocity here, which we will consider as our final velocity. Remember, at the maximum height, that ball stops a bit before it goes down, right? So the velocity there is going to be 0 meters per second. So VF, we're going to say it is equals to 0 meters per second. 0 meters per second, because at that point, the ball stops momentarily. We also know G, because we said our direction down is negative and up is positive. Which means our G is going to be the negative of 9.8 meters per second squared. 9.8 meters per second squared. So that's the unit of measure for acceleration, meters per second squared, right? What else do we know? We also know the change in y. We know the distance, the position. So we know it's from the ground, which you consider as 0, up until there. So our change in y is going to be, and the ball, in which direction is it going? It's going up. So it's going to be 0.9 meters, a positive 0.9, because we decided that up is positive 0.9 meters. It's very important for you to understand that this change in y is a vector. It's displacement, it's not the distance. Hence, it's important to either put a positive or a negative so that you don't get confused or you calculate the wrong thing, right? So we say if we know all of this, we can essentially calculate VI. There's an equation out of our 4 equations of motion that will allow us to calculate the initial velocity, and that will be the velocity with which the ball rebounds after during the first bounce, right? Okay, so you can use this equation. You can say, oh, okay, we can say VF squared is all equals to a VI squared. So that's an I, meaning initial, plus 2AG, 2G, I'm lying, it's 2G, and a change in Y. Right? Cool. What is our VF? We said it's 0, so you can just say 0 equals to, what is our VI? Our VI, we don't know, that's what we are looking for. So you write it down, V initial squared, and then plus 2 plus a 2, 9.8 is going to be negative 9.8 and then a change in y. That whole thing, the displacement of your object was 0.9. It's going up, and we said up is positive, so you just write the value as positive, right? And then you can just say 0 and put this expression here in a calculator. Then we'll have vi squared if you put that expression in a calculator, you're going to get a negative 17.64. That's what you get, right? And then we want to make vi the subject of the formula. The first step is to take the negative 17.4 on the other side of the equal sign, and when we do that, it's the operation there, the sign is going to change. You see, it's a negative, it's going to become positive. So we actually have 17.4, 17.64. I'm lying. I'll say 17.4. It's actually 17.64, and the entire thing equals to vi velocity, initial velocity squared. But we're not done. We still need to solve for vi. To do that, it means you can introduce a square root on both sides. If you do that, introduce a square root on vi squared, it's just going to be vi, and on this side you're going to have plus or minus a certain value. And that value, if you put it in a calculator, I think it's going to be plus or minus 4.2. 4,2. It's in meters per second. And now the task is to say, okay, where was the ball going? The ball was rebounding up, so meaning it was going up, and we said up is positive, meaning that our vi, so we say, okay, vi as a final answer, say vi is going to be equals to 4.2 meters per second, up, right? Or we can just write 4.2 meters per second, a positive 4.2, to mean that it's going up, right? Cool. And now we have actually found the velocity with which the ball rebounds after the first bounce. The last question we will look at is question 3.4, where the ball is in contact with the ground for 0.2 seconds during the first bounce. And then we have to calculate the magnitude of the force exerted by the ground on the ball during the first bounce if the ball strikes the ground at 6.27 meters per second. So let me show you how you would go about solving that particular problem. Okay, so we are at the last question that we will solve for vertical projectile motion for this video, right? So the statement said that the ball is in contact with I want the red one. The ball is in contact with the ground for 0.2 seconds during the first bounce, right? So it means the ball was dropped there at that height. We said that height was 1,8, and then it reached the floor after 0.44 seconds. That was the time t1 that we calculated earlier during the video, earlier in the question, right? And then it's in contact with the floor for a while, then it bounces back up until it reaches another height, then comes back down, right? And then if it's in contact with the floor for 0.2 seconds, this is the part where it's in contact with the floor. It means it leaves the floor or the ground after 0.64. So if you say 0.64 minus 0.44, you get that 0.2. So that's the time t2 on your graph. What is it that we need to calculate? We need to calculate the magnitude of the force exerted by the ground on the ball during the first bounce if the ball strikes the ground at 6,27 meters per second. So let's try to do that. Let's try to draw. This is a representation of the ground. Your ball is coming, right? It will hit the ground, and the velocity that it will have will be, it's called that initial velocity, right? Initial velocity, and we will say it is 6,27 meters. Because it's going down, that value is going to be negative, so it's going to be 6.27 meters per second, right? Meters per second. So it's always important to draw so that it gives you a clue of what's happening, right? So it will hit the ground, then it will bounce back. When it bounces back after 0.2 seconds, your ball will now bounce back. So that's your ball, and now it will be going up. And when it goes up, it will have a velocity. That velocity, we calculated it in question 3.3, and we found that velocity to be v, we call that vf after the first bounce, because that's what we're interested in. So that velocity will be, how much will that be? We said it's 4.2, if I'm not mistaken, and it's going up, so it's going to be positive, because we have already decided that the upward motion is going to be positive and the downward motion is going to be negative. So we have 4.2 meters per second, right? That's the situation that we need, and we have to find the force. How do we do that? If you remember, when we were doing momentum, there's this nice equation there where it says F net. It's in the back of your calculator. So now you see what they've done. They have now combined vertical projectile motion together with momentum. So all of these topics, they combine, they link. So you cannot just say, okay, I'm studying this alone. All of them, they link, and you need to be able to apply all of them, because it's important. So there's no standalone topic. Everything links with something else, right? So we have this equation. Given equations at the back of your question paper, right? So you have that equation, and this is what we'll be looking for. That F net, that will be the force exerted by the ground. Do we have the change in T? Yes, we do have the difference between these two, which was given to us. So our change in T is, let me just write it here. Our change in T is going to be 2 seconds, because that's the time the ball is in contact with the floor before it bounces back up. Is it 2 seconds or is it 0.2 seconds? It's 0.2 seconds. It's 0.2. That was my mistake. It's 0.2 seconds. So we have 0.2 seconds there. 0.2 seconds. This still stands. 0.44, 0.64 minus 0.44 will give you this 0.2 seconds. I'm hoping you're able to catch that, right? So we do have that. This is what we're trying to calculate. We have this. We're trying to calculate this, right? Do we have the change in P? Nope, we don't have it, but we can calculate it by just looking at this situation there. It means that we can calculate the change in P. The change in P is your momentum, and your momentum is given by this. So we'll say that it is M, given the mass at the beginning of the question, and then you have your final velocity. Remember, momentum is just mass in motion. So whenever something moves, it will have a momentum. It's the product of mass multiplied by the change in velocity, right? M, it was given to us, it's 0.5 kg. 0.5 kg. What about VF? VF on the other side will be 4.2, 4,2 meters per second, minus V initial, it's minus, because this is the minus for the formula, 6,27, which is the the velocity that the ball struck the ground with. You need to put two brackets, right? When you put that in your calculator, and when you do that, you are going to get 5.23. Let me just double check. So when you calculate that, you are gonna get something like 5.23 was the unit for momentum. It's kg meters, so you write dot meters per second, right? And then it means that now we can say, okay, F net, because we now have the change in P, the change in momentum. F net, we can now say F net. What is the change in time? That's 0.2, 0.2, and then the whole thing is just equals to 5.23, right? And we want to make F net the subject. It means we divide on this side by 0.2, even on the right hand side you divide by 0.2. Whatever you do on the right, you must also do on the left, right? And these two just divide or cancel each other, and then you are left with F net, which is equals to 26 comma something. It's gonna be 26. Trying to see that value was, it's gonna be plus, positive, so your F net is gonna be 226,17 or 18 newtons. So that will be the value of your F net. I'm just trying to check something quickly. That will be that, and because it's positive, you know that it will be going up, right? So that's how you would go about solving that problem, and this brings us to the end of question 3.4. Believe it or not, we are actually at the end of this video. I know it's been longer than any of the videos that I've made, but that is because vertical projectile is a very important topic that you need to understand. And even with everything that I've said today, it's still not done. So, read up a little bit using the information from this video on your textbook. In your textbook, there should be a chapter. It's one of the first few chapters, I think. Because if you saw, I didn't extensively talk about graphs of vertical projectile motion, which is something that you need to know. You need to know how to draw, if you're given a certain situation, how to draw the position time graph. So on your y-axis you have position, and on your x-axis you have your time. Also the vertical time, the velocity time graph, where on your y-axis you have your velocity, on your x-axis you have your time, as well as the acceleration time graph. Those three types of graphs you need to be able to know how to draw for various types of situation in terms of vertical projectile motion, because they also carry a bit of marks. I think lastly, I would say thank you so much for watching, and the only way to be able to master this topic is to just practice through a number of problems, then you will essentially get used to it. Thank you so much for watching.